Let's take a look at this LeetCode daily question. It's an easy one, called as minimum recolors to get k consecutive black blocks. We will be given a zero index string, blocks of length n, where blocks of I is either W or B. W is white color and B is black color. Uh, we are also given an integer k, which is the desired number of consecutive black blocks. In the operation, we have to recolor a white block to a black color, and we'll return minimum number of operation for this to convert a white to black, so that there is least one occurrence of k consecutive black blocks. So we'll just recolor the white blocks uh, here according to the k integer. So k is 7, so we have to return 7 consecutive black colors, and we'll convert this white to black here. We'll return the minimum number of operation that we will need to change the color of the white to black here. So constraint is 1 to 100, and block I will be either white or black, and k will be 1 to n.
We'll take a look at the first example here. In the blocks we were given white, black, black, white, white, black, black, white, black and white, and k is 7 here. Firstly, we'll make all the possible combinations of where we can find our 7 consecutive blacks here. So we'll mark the indexes here: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so one occurrence can be this from 0 to like this can be one occurrence. 1, 2, 3, 4, 5, 6, 7, this. Okay, so from 0 to 6 can be first occurrence here. Then we try with from 1 to 7 index. Then we can try with 2 to 8 index, and lastly we can try with from 3 to 9 here. Out of these four, one occurrence we can return in our solution. Okay. So 0 to 6 was white, black, black, white, white, and black and black. And for 1 to 7 was black, black, white, white, black, black, and white. For 2 to 8 was black, white, white, black, black, white, and black. And for last occurrences, white, white, black, black, white, black, and white. So we try to change the white into black here. So here there are 3 whites. Okay, so 3 whites are there. Here there are 3 whites also. Here also there are 3 whites. Here are 4 whites. As we can see that here we are taking 3 operation to convert each white into black. Here also we are taking 3 operation. Here also we are taking 3 operation, and here we are taking 4 operation. So as 3 is less than 4, so we'll return the minimum number of operation as asked in the problem. So we'll output 3 here. We'll see how to implement this with sliding window technique. So we'll mark our windows. So first window was this from 0 to 6. Then second window was this one. third was from 2 to 8, and fourth window was from 3 to 9 index. First window was W B B W W B and B, right? So now what we'll do, we will create a variable here and store 3 here because there were 3 bytes, right? Now we'll take a look at the second window. In the first window, what we did basically deleted this byte and added a byte here. Okay, so now we'll write a second window that was B B W W B B and W. This is the second window, right? Now we'll change this value to 2 here. Okay, because now there are only 2 bytes. Now from the second window, to get a third window, we'll basically remove B here and add a eighth index B here, right? So our third window is now B W W B B W and B. Now we changed our value from 2 to 3 here. For our fourth window, we'll again remove B here and add a W here from ninth index and change this value to 4 here, as there are 4 bytes. So we got our fourth window here, which is WWBB WB and W. Oh, sorry, this will be 3, right? Now we can again see that 3 is less operations than 4, then we'll return our 3 here.
Now we'll start with the code part. We define our window here as 0. We'll start with the code loop. I 0 I A I plus plus blocks blocks I white color, and will increment K is number of black color tile we need in our problem here. And we'll initialize our result here as W. And int n is number of colors in the block here. Blocks dot length. And for our next window, this is for our next window that we are sliding into. Int I equals 1 I. This is we were removing the first color and the last color. This is how we will implement this. And minus k plus 1, right? I plus plus flow at minus 1, and we'll equal this with our white color, and we'll decrement the value of W. And if block is I plus k minus 1, then we'll increment W plus plus. At I plus k minus 1 equals again W, and we'll increment now. Result will be our math dot minimum operations here, and we'll return our result here. Do not find symbol, line number 8. This will be result, right? Okay, now it should work fine. Now submit it.